Another way of running a traverse is by using the deflection angle. We define the deflection angle at the station as the clockwise, denoted by R, or the counterclockwise, denoted by L, angle measured from the extension of the preceding traverse line to the next traverse line. So supposing that we have this open traverse, the station points are A, B, C, D, and E. There is no preceding line. If you are at station A, there is no preceding traverse line. So we start at B. So at B, we have the extension of traverse line AB. And from that extension of line AB, we measure the clockwise or the counterclockwise angle. So in this case, it will be the clockwise angle going to the traverse line BC. We shall denote this as theta B, that is the deflection angle at B, and indicate the direction counterclockwise, so it should be a right deflection angle. Proceeding to station C, we make an extension of line BC, and from that extension, we measure the, again, clockwise angle going to traverse line CD, and we shall denote that as theta C in a clockwise direction. Going to station D, we extend line CD, and from that line, or from that extension, we measure the counterclockwise angle theta D going to line DE. Since it is a counterclockwise angle, we denote it by L. And at station E, there is no succeeding line, hence there will be no deflection angle at station E, right? Deflection angle traverse is also applicable for closed traverses. Say this is a closed traverse. 1, 2, 3, 4, and 5. So let 1, 2, 3, 4, and 5 be the traverse stations. So it proceeds in a clockwise direction. So at 1, we have the extension of line 5, 1. We have this theta 1, right. At 2, we make an extension of line 1, 2, clockwise angle theta 2R going to line 2, 3. At station 3, again, still clockwise, theta 3R. At 4, still clockwise, theta 4 right. And at 5, it is theta 5 right. For any closed traverse, the summation of all the deflection angles must equal either 360 degrees right or 360 degrees left. If it's a combination of right and left deflection angles, we can denote all right deflection angles are positive and all left deflection angles as negative, and it should add up to 360 net right or net left. Otherwise, we'll be applying some corrections or adjustments in our deflection angles. Let us now work on the following illustrative example. Given below are the observed deflection angle at each intermediate station in an open deflection angle traverse. Given the bearing of line AB to be north 40 degrees 30 minutes east, we determine the bearings of the other traverse lines. So we have 5 traverse stations A, B, C, D, and E. For the intermediate stations B, C, and D, we are given the observed deflection angle. So we can start at A. Let us draw line AB. North 40, 30 east. Okay. So let us indicate this angle. 40, 30. Station A. And here is station B. So proceeding now to station B, the deflection angle at B is 75-20, right? So we make an extension. Let me adjust this first. Okay. We make an extension of line AB. And from that extension, we measure 75 degrees 20 minutes in a counterclockwise or in a clockwise direction. So this is also 40, 30. This is also 40 degrees 30 minutes. Then we measure 75. Okay. There should be our line BC. Okay. And that deflection angle is 75 degrees 20 minutes. At this point, we can already determine the bearing of line BC by getting this angle. That is alpha of BC. And alpha of BC is simply 180 minus the sum of alpha of AB, which is 40 degrees 30 minutes, and the deflection angle of 75-20 in a clockwise direction. Okay, so that will be 180 minus the sum is 115.50. 179, so that will be 64 degrees and 10 minutes southeast. Alright, so we check that 40, 30, and 75, 20. That will be 115.50. Subtract 8 from 180 or 179, that is 64. 60 minus 50 is 10. Alright, so we now proceed in determining the bearing of line CD. So we are at C. We make an extension of line BC. And then we measure 100 degrees 14 minutes, or we lay out an angle of 100 degrees 14 minutes in a counterclockwise direction. No? Deflection angle is left. So that should be somewhere here. Okay. That is the deflection angle, which is 114 in a counterclockwise direction. Alright? So somewhere here will be our station B. We also have the bearing of BC. Okay, this is the bearing of BC, alpha of BC. So how do we determine this angle, which is alpha of CD? Alpha of CD is equal to 180 degrees again minus the sum of BC, which is 6410, and the deflection angle 114. So that is 180 minus 164 and 24. So subtract 164, 24 from 180, that will be 15 and 36. Okay. Again, 64, 10 and 114 is 164, 24. 180 minus 164, 24. That is 1536. 179.60. Alright. And then finally, we determine the bearing of line DE by making an extension of line CD. Okay. By the way, what is the direction of CD? It is in a northeasterly direction. Okay. So this is also alpha of CD. Alright. Then we lay out the deflection angle at D, which is 2630 right. So clockwise angle. Oops. It is a clockwise angle. There. So that should be somewhere there is our station E. So what do we want to know here at station D? We want to find this angle, which is alpha of DE. And alpha of DE is equal to what? That will be, this one is the deflection angle. No? Let me indicate the deflection angle here. That is the deflection angle at D, which is 2630. Alright. So to find alpha of DE is to just add alpha of CD, which is 1536, and the deflection angle 2630. And that will be equal to 41 or 42 degrees and 6 minutes in the direction north. Okay, let me that will be north 42 degrees 6 minutes east. Okay, now let us check our computations. Let us add up all the deflection angles. Right positive, left negative. Okay, so 7520 minus 114 plus 2630. That will be 101.50, 101.50 minus 114. So that gives me 1 degree and 36 minutes. Okay? Or should it be 46? 40, no, 36, right? 36 minutes. And that is net what? Net right. No? Right minus left plus right. So positive, so it is net right deflection angle. Okay. So let me draw line AB. Our AB is north, 40, 30. North, 40, 30, east. Okay. And then we apply at B the net deflection angle, which is 1 degree 36 minutes right. Make an extension, applying AB, and we apply the net deflection angle of 1 degree 36 minutes right. So it should be somewhere here. Okay. This is supposed to be the last line, DE. And here is the net deflection angle of 136. So we want to find the bearing of DE. We know that this is alpha of AB. So alpha of DE is equal to alpha of AB 40 degrees 30 minutes plus the net deflection angle of 1 degree 36 minutes, and that should give me 42 degrees and 06 minutes in the direction northeast, and that agrees with our previous answer. So our computations are correct, no? As far as finding the bearings of the other traverse lines are concerned. For a close deflection angle traverse, let us consider the given close traverse. We have 5 station points, A, B, C, D, and E, and indicated in our figure are the respective deflection angles at A, B, C, D, and E. Notice that it's a combination of right and left deflection angles. So as mentioned earlier, for any closed deflection angle traverse, the sum of the deflection angles must equal 360 degrees right or 360 degrees left. So right deflection angles are positive and left deflection angles are negative. In the case that the net deflection angle is neither 360 right or 360 left, say for example, it is 362 degrees right, there is a discrepancy of 2 degrees right. So we need to say that clockwise deflection angles are 2 degrees more than the left deflection angles. So if there are 5 station points, what you do is simply distribute the error over all the 5 deflection angles. Let's say n is equal to 5. N is equal to 5. The correction will be 2 degrees divided by 5, and that will be equal to 12 minutes. So for all right deflection angles, subtract 12 minutes from each right deflection angle and add 12 minutes to each left deflection angle. Alright? So same thing if it is 360 degrees left. If the sum is more than 360 degrees left, then you have to divide the total discrepancy over all the deflection angles. Okay? As an exercise, you work on the following problem. So we are given the observed deflection angles for a closed traverse, adjust the deflection angles for some observational errors. Also, determine the bearing of the traverse lines given the bearing of line AB to be due north. So you have 5 station points, A, B, C, D, and E, and the observed deflection angles are indicated in the table. So you can start at A by sketching line AB due north. So that is AB. And then at P, you apply the deflection angle. 80 degrees and 20 minutes right, so it should be in a clockwise direction. There. So that is 80 degrees, 20 minutes right. Then at C, the deflection angle is 92 degrees and 30 minutes left, so it should be somewhere there. Station D. 92 degrees, 30 minutes left. Okay, so you can sketch the other traverse lines and it should form a closed traverse. No? So you can just adjust the traverse distances in order to come up with a closed traverse. So again, you have to check the summation of the deflection angles, and that must be equal to 360 degrees right or 360 degrees left. Say for example, the sum is 358 degrees and 20 minutes right. So it is 1 degree and 40 minutes shy, no, of the required sum. So you have to distribute this according to the number of traverse stations. You divide it by, in this example, it will be 5. Divide it by 5. And that will be the magnitude of the correction. So since the sum is less than the required, 360, you have to add the correction, no, for the right deflection angles and subtract it for the left deflection angles. Okay? So the same thing if the sum is less than or greater than 360 degrees left. Okay?